Hi guys, so about the seashells. I love seashells, I love being by the beach, and so I decided to make my cladogram about classifying seashells. I don't know that much about them, but I did a little bit of research, but mainly I just based my cladogram based on the observations I made from the shells that I picked out. So see what I do, and then if you like, you can make your own. So these are the 6 seashells that I picked, and now I'm going to try to classify them on a cladogram based on their physical characteristics. The first thing I try to observe is what is a common characteristic of all the seashells I've selected, and that's that they're made out of really tough material. The next thing I notice is that there are 2 that are very similar to each other. I did a little research and I found out that these are from bivalves, organisms like clams and oysters. There are several observations to be made with the other 4 remaining shells. To start with, I noticed that one was very spiky, while the other 3 were very smooth. Besides being spiky and smooth, 2 of the shells look like they could be snail shells, while the other 2 not so much. Another observation is that one of the shells just was not as swirly as the other 3. It's important to jot down all your observations and then do a little bit of analysis. I eliminated smooth because that's basically the opposite of rough. I did keep spiky though because that's really a defining characteristic of that one extreme type of shell. Definitely circling tough material because that's the characteristic that they all share. Bivalves because that's definitely a defining characteristic for 2 of the shell. Swirly because that's a characteristic shared by the other 4. And finally, I'm going to keep not as swirly because that really defines the one shell. Spiky the other shell. And then I think I can make a cladogram chart if I separate the swirlies for the ones that look like snail shells versus the ones that don't. I've arranged my shells numbered 1 through 6. It doesn't have to be in any particular order. And I've arranged my 6 different characteristics that I'm now going to analyze on the characteristics chart. This is the final characteristics chart. I've marked every single seashell based on whether they had the characteristic or not. Some trends to note. First of all, there's a check mark for every single seashell under tough material characteristic, which only makes sense. Looking at the other extreme, for spikes, there's really only 1 seashell that has spikes. You can keep analyzing trends from most common to least common, and that will help you set up your cladogram. Looking across the rows, it looks like there's a tie for the bivalves because they each have the exact same 2 characteristics. To set up the cladogram, you start with the characteristic that all the organisms share, and you put that at the bottom of your line. So mine will be tough material. Going back to the chart, I noticed that bivalves really only share the common characteristic of tough material. Other than that, they're bivalves. I must place the bivalves here because they have none of the other characteristics on the chart. Now I look for the second most common characteristic if I eliminate bivalves, and that's spiral shape. As you can see, the remaining 4 shells are all spiral shaped. After tough materials and spiral shape, the next most common characteristic would be many whorls. One of the spiral shaped seashells doesn't have very many whorls, so 3 get to move on the cladogram while the other remains behind. Back to the chart, I look at the column that has 2 check marks, and that one would be snail-like shells. I know bivalves also has 2 checks, but we've already accounted for those guys. Out of the 3 remaining shells, 2 of them look very much like snail shells. That leaves us with the last remaining characteristic, which is spikes. This is the final cladogram based on those characteristics. It's important to note a couple things. Number 1, the characteristics go on the bottom of the chart. The organisms go on the top. Where I have numbers, scientists would put the proper names of the organisms for each of the species that they've classified. Keep in mind, the cladogram is a hypothesis or a guess as to how organisms are related based on some common characteristics or features that they exhibit. I hope this has helped you understand how scientists work to put together the tree of life, and I encourage you to make your own cladogram.